Hey guys, and welcome back to another great episode of Damos in the Class. Today, we're going to keep on diving in with fractions. We're going to be moving on to mixed numbers and improper fractions. So come on guys, let's go and get started. Today's aim is adding and subtracting mixed numbers. We're going to also be decomposing and composing mixed numbers. Alright, so today's first three practice problems, we have our first one is 7 over 8 plus 6 over 8. Then we have 3 over 9 plus 6 over 9. And then our last one is going to be 5 over 12 plus 9 over 12. So we're going to go ahead and start with the first one. Our first one is 7 over 8 plus 6 over 8. So as we remember from our rules and we've been working, that we already have like denominators. So with that being said, we should already know that our denominator is going to be a 8. So I'm just going to go ahead and set up for my 8. Now that we have our denominator set, we can go ahead and circle our numerators. Again, this provides us with our exact number sentence that we need to write so we can solve for our numerator's answer. So we're going to then write 7 plus 6 equals, and then we're going to do that math. So if we're at 7 and we're going to count up 6 times, let's go ahead and all do it together. 7, we're at 7, so we don't count 7. Our first jump is going to be 8. So let's start counting.
8, 9, 10, 11, 12, 13.
All right, so now as Jamia helped me count, we got an answer of 13. So that is going to be what we're going to put on top for our numerator. So now that fraction becomes 13 over 8. That is what 7 over 8 plus 6 over 8 gives us 13 over 8. But as we both, all of us have learned, right, that there's a such thing called as an improper fraction. This would be a prime example of what an improper fraction looks like. Why? Because the improper fraction means that our numerator is greater than our denominator, which means 13 is bigger than 8. And we all know that 13 is bigger than 8. So this type of fraction is called an improper fraction. Now, we can't leave it like that. Or we can. It depends on the test that you're taking or who you're taking or answering to and what the choices are. But to be efficient in math, you want to know all variations of the answer. So this is an answer to the question. However, it is not the only answer. And in math, it's something that you want to become is precise. So knowing that there's more than one way to represent this answer, I'm going to strongly advise that you always transfer your improper fraction into a mixed number. So that's what we're going to go ahead and do. How do we do that? We start out by taking our same numerator that is greater, and we just go ahead and put that inside of a division house. And why do we do that? Because this fraction line, it represents dividing. So that's exactly what we're doing. We're going to now have 13 inside the house, and now our 8, that is our denominator, that is our divisor number. So now we need to know how many groups of 8 can we get out of 13. So Jamir, how many groups of 8 can we get out of 13?
One group.
That's correct. We can get one group out of 13. So then we're going to go ahead and do the multiplication. 1 times 8 is how much?
8.
All right, so we put that 8 right up underneath the 3. We draw our subtraction and our equal sign. We're at 8. We're going to count up to 13.
9, 10, 11, 12, 13.
and we're going to get 5. Now that we got that 5, we take that 5 and we move this up here to the top with our answer, and we make that our numerator, and we keep the same 8, and that is our denominator. So now we have a new answer of 1, which is a whole number, and a fraction of 5/8. Now, both these two represent the same amount, which means they are equivalent. 1 is an improper fraction, and 1 is what we call a mixed number. Alright, so now for our second problem, we have 3/9 plus 6/9. We're going to continue, as always, doing the same exact steps. We notice that our denominators are the same, so we just go right on in and we set our denominator to be the same, which is a 9. Then we go on in and we circle our numerator, which creates our number sentence. I'm always going to write my larger number first, so I'm going to write 6 plus 3. It will get me to the answer quicker. I'm at 6. I'm going to count up 3 times, Jamir.
7, 8, 9.
And I'm going to get 9. Alright, so what do we do with this 9? This 9 now becomes, my marker's trying to go down, guys. Give me a second. So now we have a 9. We're going to put that 9 over top our denominator, which is a 9. So what do we have now? 9/9. And what does that equal?
9/9
Equals what?
equals 1.
There we go. Good job. 9/9 definitely equals 1 whole. Why? Because our total number parts are all shaded in. So that equals 1 whole piece. And I hope you guys remember that too. And if you did, give yourself a round of applause, because you deserve it, and a pat on the back. Great job, guys. Alright guys, so we're just going to move on to our third practice problem here. So we got 5/12 plus 9/12. And I know everyone knows we're going to make that a 12. That's right, guys. And then we're going to circle our numerator. We write our 9 plus 5. We count up 9 from 5.
10, 11, 12, 13, 14.
All right. Now we got 14/12. I hope someone noticed. Do you notice? 14/12. What that look like to you?
Improper fraction.
Improper fraction. Good caught. Why? That numerator 14 is bigger than 12. So what are we going to do? We're going to put that 14 inside our house, right? We're going to put our 12 on the outside of the house. Now, 12 and 14 is so close that we know we only could get one group of 12 if we got 14, right? So now we're going to go ahead and do that multiplication. 1 times 12 is going to give us 12. We're going to do a subtract and an equal sign. We're at 12. We're just going to count up to 14.
13, 14.
And that's going to leave us with 2. Great job, Jamir. So we got that 2. We're going to bring that 2 up on top. That's going to be our numerator. Then we're going to go ahead and fill in our denominator as the 12. So guys, I hope someone else is noticing. Jamir, do you notice? I know somebody noticed. I know you guys know. That's right, you guys know. We don't leave it right there either. Why? Because we got even numerator and an even denominator, right? So anytime we got even numbers, we know we can always reduce. Reducing is very important. That's to get the answer to be exact. Remember, math, we're looking for exact and precise. So we got to take this down, even if it's only by 2. So our denominator is 2. Normally, we'll make a whole list, but actually, just so you don't forget the steps, I'm going to go ahead and make the list. we're going to go ahead and write out our factors for 2. So that's the first thing we need to do in order to simplify. So 2, I can make 2 doing 1 times 2. That is the only way I can make 2. Now, we're going to look at 12. I can make 12 1 times 12, 2 times 6, and 3 times 4. Those are the 3 ways that I can make 12. These are called the factors. I know somebody just said it. I can hear you. That's right. These are the factors. So like we know, we do not use the number 1. But the rest of these are definitely the factors. So 2 only has a factor of 2. Right? But 12 has 12, 2, 6, 3, and 4. But the thing is, we need to find our, what do we call it? What do we call this?
GCF.
There we go. We need to find our greatest common factor, which means which one do they share. So we see it's only the 2 is the only one that we could use. So if we got a 2 up here and when we can find the 2 down here, that means we can use it. Do you see a 2 down here? I know you guys see the 2 too. Right there. So that's exactly what we're going to use. We're going to use the 2. I'm just going to let you pause for 1 second just to make sure you created your factor list or that you just want to make sure you get to this step first. Alright guys, so we said we're going to use that 2 and we're using it to divide. So we're going to put our division symbol, we're going to put our 2 on top and our 2 on the bottom. That's the numbers that they share. And we know if we only have 2 and we divide by 2, we only could do that 1 time. So our top number is going to be a 1 for our numerator. And our bottom number, we already know that multiplication is the opposite of division. We know that 2 times what will give us 12? 2 times what give us 12, Jamia?
2 times 6.
There we go. 2 times 6 gives us 12. So that means 12 divided by 2 will leave us with 6. So now, when we go to write our answer, it's going to say 14 over 12 equals, we have a whole, we can't forget that, 1 whole and 1 over 6. That will be the complete, precise answer for the problem 5 over 12 plus 9 over 12. Mixed number, whole number, and a fraction. I wanted to write this down for you so you can add this to your notes because hopefully you are keeping notes. Last week I did go over improper fractions and gave definitions for everything. If for some reason you didn't catch that one of my other videos, they definitely have all the definitions that you need and all the terminology that I use in each and every video. Decomposing, composing, equivalent, simplifying, all of those are in my previous fraction videos. So if you don't have those definitions, if you look back, you can definitely find them. But I do hope that you are copying them down so you can have them as a reference as you continue to learn. Alright, so now we have 3 practice problems that we will be using mixed numbers and adding. So our first one is 1 and 1/4 plus 3 and 2 over 4. Our second problem is 2 and 5 over 8 plus 3 and 1 over 8. And our last problem is going to be 3 and 2 over 7 plus 2 and 6 over 7. So we're just going to take them one by one, starting with the first one. And guys, like I always told you, this is just how tests may come up, or your practice homework, or homework from your teacher. And that's perfectly fine if they write it this way. But it's also perfectly fine for you to rewrite it to make it best for you to solve. And as I tell you, and I will continue to tell you, that writing your problems from greatest to least will always make it easier. So we're going to do that. I'm going to rearrange this problem here because I know that my whole number 1 is smaller than the 3. So I prefer to have this fraction on top of that one. Well, this mixed number, which is a whole number and a fraction together. That's what a mixed number is. So this mixed number needs to be on top. So I'm going to write 3 and 2 over 4 plus 1 and 1 over 4. I'm going to draw my equal sign to let us know that that is an equation. So, when we're working mixed numbers, the first thing we want to do is deal with the fraction side of the problem. So that's what we're going to do. And we're going to use the same rules that we've been using. We're going to look at our denominators. And you can see, Jamir, what are the denominators?
The 4s.
Right, so a denominator is 4. So we're just going to go right in, and we're going to go ahead and keep our denominator as a 4. And just like fractions, we are going to circle our numerators. Why? Because that let us see exactly what our number sentence needs to say. So now we're going to go ahead and we could write into that number sentence or in your head, whichever one is easy for you. But while I'm showing you this, I'm going to show you what is going on in my head, which is me solving this equation of, find a little space, I'm going to erase our original one since we're not using that, and I can use this space. Just like I advise, when you're working your problems, you find space on the side of your paper to work. So I'm going to now write my number sentence, 2 plus 1 equals. I'm at 2. I only need to go up one time, so we all know that should give us a 3. So that's going to be the answer for my numerator. Just like any other fraction problem, we have an answer of 3 over 4. So now, guys, we are done with this side of the problem. Now all we need to do is concentrate on our whole numbers. So we just go ahead and we can see that very easily. We have a 3 plus 1. And as we see, we're at 3. We just need to go up one time. So if we're at 3, we went up one time. Where are we at?
4.
We're at 4. So now we have an answer of 4 and 3 over 4. That is the answer for 3 and 2 over 4 plus 1 and 1 over 4 equals 4 and 3 over 4, or 4 and 3/4. Alright, so now we're going to move on to our second problem. Again, we have 2 and 5 over 8 and 3 and 1 over 8. And for me, the same thing applies. So I am going to go ahead and do the same exact thing. I'm going to write 3 and 1 over 8. And then I'm going to write my 2 and 5 over 8. That is what's comfortable for me. Then I have my larger numbers first. I'm going to erase this original problem just because I need the space. And guys, I'm left-handed, so that didn't work for me. Oh, sounds like fireworks. Sorry about that. Getting close to the holidays, so people are holiday in it. So, yeah guys, those are fireworks. But we're going to keep going, working through it. Because maybe they know about the celebration that we are learning fractions, guys. Yay! Alright, so, like I said, we're going to work. The first thing we do is we look at our denominators. And our denominators are what, Jamia?
8.
We got 8 for denominator, so we just go right in for our 8. Then we go ahead and we circle our numerators. Our numerators gives us a sentence of 5 plus 1. That's only 1 up from 5, and everyone should know that'll be a 6. So now we have 6 over 8. We see those are even numbers. I'm going to get to that in 1 second. Well, matter of fact, I like to do it immediately so you do not forget. So as you see, guys, we ended up with 6 over 8, right? Our number sentence was 5 plus 1 gave us 6. We have 6 over 8, but these are both even numbers because our evens, if anyone's forgotten, is 0, 2, 4, 6, and 8. Any of those make the numbers even. We never look at our tens or hundreds. We only look in the ones. So therefore, 6 and 8 are evens. So now we know we have to reduce. What can we reduce by? Once again, we always look for our GCF, and we make our factors. So I'm going to go ahead and I'm going to write the factors of 6. So we have 1 times 6 to give us 6, and we have 2 times 3 that'll give us 6. And then for 8, we have 1 times 8, and we have 2 times 4. Those are the 2 ways to get 6 and the 2 ways to get 8. We know we cannot use our ones, so we look to see what do they have in common. What do 6 and 8 share as far as the GCF, Jamia? What number do they share?
A 2.
Exactly, they share that too. So we're going to go ahead and we're going to divide our 6 over 8 by 2 over 2. Which means 2 times what gives you 6, Jamia?
2 times 3.
Exactly. 2 times 3 gives you 6. That means you get a 3 for your answer. 2 times what give you 8, Jamia?
2 times 4.
Exactly. So 4. So we have a new fraction of 3/4. So that's what our answer needs to have. We need to have 6, 8. Let me write this so it doesn't confuse you. I'm going to move our sentence here. And I'm going to write what needs to say on your paper. 6 over 8 equals 3 over 4. But we have to also get our whole number to add to that. So Jamir, looking at the whole numbers, we're done with the fraction side. Because 6 over 8 turns into 3/4. But we have to answer our whole number side. We got 3 plus 2 is how much?
4, 5.
Exactly. So therefore, our answer is 5 and 6 over 8, which really equals 5 and 3/4. And that is the answer to 3 over 8 plus 2 and 5/8. The answer is 5 and 6 over 8, which also equals 5 and 3/4. Alright, so now for our last practice mixed number of addition, we have 3 and 2 over 7 and 2 and 6 over 7. But for this problem, it's actually written correctly because our whole number is 3 and it is larger than our whole number 2. So this is the larger number, so it should be on top, and it works perfectly for me. So we're going to go ahead and we're going to go immediately. We're going to look at our denominators. We're going to go ahead and write in our 7. We're going to circle our numerators. We're going to write our 6 plus 2 equals, that's right guys, 8. And we're going to put that 8 over top the 7. But what's the first thing we see when we put that 8 over the 7? What does that mean?
Improper fraction.
Improper fraction. Good job. So we need to put that 8 inside of a house, our 7 right on the outside of the house. We know if we only got 8, how many times can we get 7? We can only do 7 one time. So 1 times 7 is going to give us 7. We're going to subtract. We're at 7. We only need to get to 8. That's going to be 1. And now we have a numerator of 1, a denominator of 7. So now 8 over 7 equals 1 and 1 over 7. So we know that this part of the fraction we definitely have to keep, right? So that's what's going to come over here to our answer. 1 over 7. Because it's no longer the 8 over 7. We turned it into 1 and 1 over 7. So I'm going to put it right where it needs to be, which is underneath the fraction side of the problem. That 1 7. But you see this whole 1 right here? That's a whole 1. We have to add that into our whole numbers. We can't forget about it because it is a part of the answer. So now we have 3 plus 2, and as we know, that's 5. But if we add 1 more, then now that's 6. So now we have an answer of 6 and 1 over 7. That would be the precise answer for 3 and 2 over 7 plus 2 and 6 over 7. Alright guys, so now we are going to work 3 subtracting of mixed numbers. And our first problem is 5 and 3 over 7. Take away 1 and 2 over 2. Our second problem will be 4 and 3 over 8. Take away 2 and 1 over 8. And our third problem is going to be 7, 5 take over 9. Take away 4 and 2 over 9. So let's start working with our first problem. And like we did, more practice with our fractions. So we will always start with that first. We're going to go ahead. We see our denominator is a 7. So we go ahead and make that a 7. We are going to do the same exact thing, which is circle our numerator. This time we make sure we pay attention to our operation sign. And that's 3 take away 2 equals 1. So we have a fraction of 1 over 7 for our fraction side of this problem. Now we're going to just go ahead and look at our whole numbers. That should be simple enough. We have 5 take away 1, which is the same as being at 1 and just counting up to 5. And if we do that, 2, 3, 4, and 5 will give us an answer of 4. So the answer to 5 and 3 over 7, take away 1 and 2 over 7 would be 4 and 1 over 7. Alright, so now we're moving on to number 2. We're going to do what? Look at our denominators and what we're going to get.
8.
Alright, so our denominator is an 8. And then now we're going to do what? Circle our numerators. Okay, then what's our number sentence?
3 take away 1.
Alright, 3 take away 1. And what is that answer? We have 1. We count up to 3.
2, 3.
And now we have 2 over 8. Is there anything that you notice about 2 over 8?
Improper fraction.
Nope. Good try, but no. Look at it again. What else do you notice? That's improper fraction means that your numerator would have to be bigger. 2 is not bigger than 6. So it's not an improper fraction. It's what? It needs to be reduced. It needs to be simplified, right? Because there's even. That's what you're supposed to notice. Remember?
Yeah.
0, 2, 4, 6, 8. All of those are your even numbers. If your fraction come up with an even number, you know that you need to take it down. Even if it's just one time, then that's it. But you try to find the biggest number that they share in between to get you to represent the same fraction in its simplest form. So Again, that means knowing your multiplication. I'm not going to write it out because everyone should know that 1 times 2 gives us 2. That's the only way that we can make 2. However, we cannot use the number 1. So 2 is going to be the one that we use from the 1 and the 2. Then when we look at 8, we can make 8 with 1 times 8. We don't use the 1, so we only can use the 8. So with that being said, 4 times 2 gives us 8. And as we hear, they both share the 2. So we're going to divide by 2 over 2. So we're going to put our division signal. We're going to put 2 over 2. We know if we have 2, we divide by 2. We only can do that 1 time. And we know 2 times what? Give us 8.
2 times 4.
All right. So now we have a new fraction of 1 over 4. So our answer should be in our answer as well. But I'm going to write the total answer in just a moment after we do our subtraction of the whole numbers. So now we have 4 take away 2. That means we're at 2. We only need to count up to 4. So what's the answer?
3, 4.
All right, so that leaves us at 2. So that means your whole answer should say 2 and 2 over 8 equals 2 and 1 over 4. That would be the answer to 4 and 3 over 8 take away 2 and 1 over 8. Alright, and so for our last problem, we got 7, 5 over 9, take away 4 and 2 over 9. So we're just going to go in, and Jamil, what is our denominator?
Ooh, the 9.
Alright, good job. And we do what? Circle, circle. What's our number sentence?
5, take away 2.
And what's our answer?
3, 4, 5. 3.
Okay. So, y'all guys know anything about 3 over 9? If we know our multiplication. So, to say what you know.
We have to reduce it.
Oh, shoot. That's what you know. That's what I'm talking about. That's right. We got to reduce it because I was just about to say, but Jamil didn't stop me. Yeah, the same way we do it for the even, we got to do it for the odd, guys. So, let's remind you if you don't know. We got our odd numbers. Our odd numbers are 1, 3, 5, 7, and 9. If we get those, we might could get a group to make those even smaller. So that's what we got. We got a 3 and we got a 9. We got to do the same thing, guys. We need our G, C, F. Okay? But this time we're looking for it out of 3 and 9. So we're going to go ahead. I'm going to come over here to my left side because I'm left-handed. So we're going to make how can we get 3? So 1 times 3, that's the only way we can get 3. We know we cannot use our 1. So the only factor for 3 we could look at is going to be the 3. Same thing with our 9. We need to make 9. We could do 1 times 9. Or we could do 3 times 3, guys. And we know we can't use that 1. So the factors of 9 is going to be 9 and 3s. Which you don't say 3s twice. You just say 3 once because it's the same number, right? So what number do they obviously share? They share 3. Exactly. So we can reduce 3 over 9 by 3. So that means we're taking a group of 3 from each one. And if we take a group of 3 out of 3, we only could do that 1 time, guys. And like we looked in here, it says 3 times 3 gives us 9. So 9 divided by 3 is going to give us what? What does it say? 3 times 3 give you 9. So 9 divided by 3 give you how much?
3.
That's all it could give you. And so the answer on this side is going to be 1/3. We're going to write the full answer in, but I'm going to give you a second to grab that first. Alright guys, so the only thing that's left is we're going to look at our whole numbers. We got 7 take away 4. That means we are at 4. All we need to do is count up to 7.
5, 6, 7, 3.
Alright, so we have an answer of 3 for the whole number. So the whole answer is going to be 3 and 3 over 9. I'm going to write it the right way so your teacher or whoever wouldn't get confused. So it will be 3 and 3 over 9 equals 3 and 1/3. That is the answer to 7 take away 5 over 9. Excuse me, 7 and 5 over 9 take away 4 and 2 over 9. The answer would be 3 and 3 over 9, or 3 and 1/3. So many threes, guys. Little tongue catcher. Tongue twister. Alright guys, so for the last part of this video, I want to work on mixed numbers and improper fractions. I want us to be able to create an improper fraction from a mixed number, and vice versa, a mixed number into an improper fraction. Then I hopefully would like to show you how to decompose and compose the same fraction. Depending on how it's going, we may or may not decompose. But right now, we definitely will do going from mixed numbers to improper fraction. So our first one is 1 and 5 over 6. That is what we call a mixed number. Why? Because we have a whole number and we have a fraction. So in order to change this into an improper fraction, we need to then, as we know, this means divide. So we always do the opposite. We are going to multiply. So we're going to multiply our whole number by our denominator. Now, that's going to be 1 times 6, which is 6. Then we are going to add our numerator. So now we have 6 plus 5. So if we're at 6, we're going to count up 5.
7, 8, 9, 10, 11.
So we have 11. That is what our numerator is now going to become. Our numerator is going to become 11, and we are going to keep our denominator of 6. So now 1 and 5 over 6 is equivalent to 11 over 6. That's how we will get our improper fraction from our mixed number. So we're going to continue on to the second one and doing the same exact thing. So again, guys, practice, practice, practice your multiplication. So we have 3 times 5. An easy way is just counting by 5s. Come on, Jamir.
5.
No, yeah, we're doing 3 times 5, so we only need to do it 3 times to get the answer.
5, 10, 15.
There we go. So now we have 5 times 3 equals 15, but we have to add our numerator. And our numerator is 4. So we're going to add 4 to that 15. So you was just at 15. Now count up 4.
16, 17, 18, 19.
Alright, so now we have the answer of 19. So that is what our numerator should say. Our numerator should now say 19, and our denominator will stay the same at 5. Those two are equivalent. Alright, so we're doing the same exact thing. We're doing 6 times 5. We can count by 5s, which is the easiest way to get the multiplication of 6 times 5. So what is that, Jamir?
5, 10, 15, 20, 25, 30.
Alright, so we got an answer of 30. But we need to add our numerator, and we have a 2. So 30 plus 2 Either you could just move the 2 over into the 1's place because there is a 0, and it would just become 32. So your numerator would say 32, and your denominator would still be the 5. Alright, so now moving on to number 4, we have what we know is an improper fraction because our numerator is greater. So we are going to then put our numerator inside our house, our denominator outside of the house. We know that 7 times 2 is how much?
7 times 2 is 14.
Alright, so now what? You said 14, but we got 11. So how many groups do we need? How many groups do we get?
Be one group.
That's it. So we got 1. That goes over our 1 in the 1's place. We do our multiplication. What's 1 times 7, Jamir?
1 times 7 equals 7.
Alright, we put our 7, our subtraction, and our equal. We're at 7, we count up to 11.
8, 9, 10, 11.
How much is that? 4. So now our 4 is our numerator and 7 is our denominator. So now we have an answer of 1 and 4 over 7 to be the mixed number for the improper fraction of 11 over 7. Alright guys, so we have this one, which is 15 over 3. We do the same thing. We're going to put our 15 in the house. We're going to put our 3 on the outside. Now we need to know how many groups of 3's can we get out of 15. How many groups of 3's can we get out of 15? Let's see how much of your multiplication do you know. 3 times 2 is what?
3 times 2 is 6.
Alright. But we didn't get there yet. So what's 3 times 3?
3 times 3 is 9.
Alright, we didn't get there yet. What's 3 times 4?
3 times 4 is 12.
Alright, we almost there. What's 3 times 5?
3 times 5 is 15.
Oh shoot, we got there. So 3 times 5 give us 15. So he said 5 groups to get us there. 5 times 3 will get us 15. Take away, so 15 take away 15 is what?
0.
0. So the answer is what? A whole 5. It's not a fraction. Our answer is a whole number 5. The answer to 15, because this is technically 15 divided by 3, either which way you look at it, because this bar means divide. But 15 over 3 still equals 5. Learn your multiplication, it makes it easier. 1, 2, 3. That's it. Alright, for the last one on these practice problems, guys, we got 22 over 4. We're going to do the same thing. We're going to put that 22 in the house. We're going to put the 4 on the outside. So now we're going to think of groups of 4. How many groups of 4 can we get to get us? Well, first we look at the first number. Our 4, we look at that first number. Is 4 bigger than 2?
No. Yes.
Which one is it? Yes or no?
Yes.
Alright. 4 is bigger than 2. So now we have to look at both numbers together. We don't skip a number. We look at them together, and together that gives us 22. So now we have to know how many groups of 4 can we get out of 22. So we're going to do the same thing, guys. And again, if you knew your multiplication, you can get there really, really quick. So, but we're still working on it, so let's work on it. 4 times 2, guys, is what?
4 times 2 is 8.
Alright. 4 times 3 is what?
12.
Alright. 4 times 4 is what?
8.
No. You was just at 12. It's okay. 4 times 4 is what?
18.
No, you jumping too high. You're not thinking. You just yelling. Think about it. You was just at 12. So if you don't know, what you need to do? Count up 4 more from 12. Wouldn't that be an easy way?
13, 14, 15, 16.
Alright, so 4 times 4 is how much?
16.
There we go. So if you add 16, count 4 more up.
17, 18, 19, 20.
So that means 4 times 5 is how much?
22.
That's not what it said. What did you just say?
20.
So then why are you saying 22? 22 is where you're trying to go. I'm not asking you to tell me what's on the board. I said 4 times 5 is what?
20.
That's what you need to know. If you do it one more time, would you go past 22?
Yes.
All right then, so how many groups of 4 would it take?
It will take us 5 groups.
All right then, so let's go with the 5 groups. Great job. Mistakes and all. You got to make them to get there. Great job. So now you do the multiplication. 5 times 4 is what?
5 times 4 is 20.
All right, so we put that 20 underneath the 22. Subtract and an equal. You're at 20. All you got to do is count up to 22.
21, 22.
So how many is left?
2.
All right, so we bring that 2 up. That's our numerator, and then we have a 4. What do we notice in this fraction? 2 over 4. What are those? 2 is a what, and 4 is a what?
Even number.
Good job. So they're even. We're going to go ahead, and we're going to look for the GCF. But this should be super, super, super easy, guys, because we only can make 2 with 1 and 2. We can't use 1, so we only can use the 2. And we only can make 4 with 1 and 4, but we don't use the 1, so we only can use the 4, and 2 times 2, which is still just 2. So the only one we can use is 2, guys. So, therefore, our answer is going to be 5. We're going to divide this 2 over 2. And then we're going to have 5 and 2 over 4 equals 5 and 1 over 2. And that is the answer to 22 over 4. To be equivalent as a mixed number, this would be it. Alright guys, so that concludes the end of this video. I hope you got a lot out of it. And please stay tuned. We will go over decomposing and unlike denominators with fractions. So until the next time, it's not about what you don't know, but it's always about what you're willing to learn.